So now أقدم السيد ريتشي براغلي. حصل السيد ريتشي على درجة الهندسة الكهربائية من جامعة ولاية كاليفورنيا في عام 2002 والماجستير في الهندسة الكهربائية من جامعة ولاية كاليفورنيا لونج بيتش في عام 2008 وهو عضو بارز في منظمة ال IEEE ومهندس معتمد للصيانة والموثوقية من الفئة الثانية وقد انضم إلى أرامكو في عام 2012 كمهندس كهربائي في إدارة هندسة أنظمة الطاقة وإدارة الأصول ويعمل الآن حاليا في برنامج إدارة دورة حياة المعدات الكهربائية وبرنامج التخفيف من حوادث القوس الكهربائي. سيكون موضوع محوره هو السلامة الكهربائية للقوس الكهربائي في المعدات الكهربائية القليلة الاستعمال. فلنرحب به. Go ahead.
Thank you, Mr. Chairman. Thank you to the organizing committee for inviting me to this safety symposium. Good afternoon, ladies and gentlemen, and thank you for everyone who stuck around to the very last presentation. I truly appreciate it. And I hope you get some good information out of my presentation. So you can see the title. Basically, we've talked a lot about arc flash, over the past 2 days. Talked about PPE, doing studies, doing the risk assessment, job safety analysis. I'm going to try to tie in these two important subjects, aging and obsolete electrical equipment and arc flash safety, to the title of the session, which is doing preventive maintenance, the role of preventive maintenance in being electrically safe, especially for our electrical workers. So a quick outline. A lot of the information has been discussed, like I said previously, with electrical and arc flash safety. So with the arc flash, so I'm not going to go deep into the arc flash portion. Then I'll just go into the aging and obsolete electrical equipment. There are actually two separate topics. So you have some that are old, but they're not obsolete. And then you have some equipment that are old and obsolete. Typically around 25 or more years. Like in our case, we have a lot of equipment that are 30 years old, 35 years old, and some are even pushing 40 years in service. So I'm not sure if some in this room are dealing with that same challenge. So hopefully you get something out of this. And then mitigation solutions, the previous presenter went into that very deeply, so I'm just going to talk about the solutions that's specific to the aging and obsolete equipment, what we can do to make it safer for our workers. So a quick definition for arc flash is the definition of 70E and IEEE 1584, a dangerous condition associated with the possible release of energy caused by an electric arc. So you can see the word possible is bold and red, so it doesn't mean it happens all the time. So you can see probably happens a very few percentage. Some workers have worked 20, 30 years in the industry, have never been exposed to arc flash. Maybe that's because of they're good electricians. Maybe because of luck, maybe because of the safety programs. But again, just to highlight it, it doesn't happen all the time. Just maybe something fails, a bolt comes out and shorts out the bus. That's a... Oh, yeah, I'm going to play this video here. So I'm not sure if any of you have seen this video before. So you can see the destructive power of an arc flash. Well, it's obvious from the video. You can see the injury to the worker because of the exposure to the heat, exposure to the fireball and then the blast. But then also you got to think about the damage to the equipment. So it's not just arc flash safety, personal safety, but also reliability. Depending on how big that blast is. If that switchgear was pretty much destroyed, then how do you restore the system? You pretty much have to bring in new equipment. You have to bring in temporary equipment to power your equipment, to power your process. So it's not just personal safety, but also reliability and process uptime. So we know from that from the video you saw the danger of the arc. Then also from the previous presentation, you talked about power, distance, and time, the factors that affect arc flash. So I'm going to tie that in and how that relates to arc flash safety and aging and obsolete equipment. For some reason, the slides are not working. But the slide shows is the influence of clearing time, which was really pointed out in the previous presentation, that clearing time was the greatest influence on arc flash. That if you increase your clearing time, then it makes it dangerous because it increases the arc flash energy. So if you've done a study and then you figure out what the energy is, and if your equipment doesn't clear the fault within the specified time that you expect it to clear, then you can pretty much throw out the study out the window because it doesn't mean anything. If you calculated the energy was 5 calories per centimeter squared and your relay doesn't operate or your interrupting device doesn't open, then it's a very, very dangerous condition. That's when the arc flash energy increases, so you increase the risk to your worker, and then you have, if it doesn't open at all, then you have, could be dangerous to the equipment. You can pretty much burn down the substation. So knowing what those factors are gives you some insight on to how to control it. So there's engineering controls, which is the most effective. The goal of engineers and safety professionals is we have to do everything that we can to mitigate the risk, to lower that energy before we put somebody in front of that gear and tell the guy, here's the suit, put this on, and hopefully you're still in one piece after you switch that equipment, right? And also the next one would be administrative, doing the training and certification for our workers, work procedures, doing proper work procedure. There was a presentation yesterday that I think it says 88% of incidents is caused by human factor. So right there is you take care of a lot of the issues by doing training and certifying personnel, and also doing documenting the proper work procedure and how to do their certain tasks. And then really the goal of my presentation is PPE is really the last line of defense. So we should focus more on the first two, engineering and administrative portion, and then if we can lower that energy enough where, well, then maybe it's just 5 calories or 8 calories, and then our worker would be much safer because if an arc flash were to occur, the energy won't be too high, the blast pressure won't be too great, and then hopefully the worker will survive. So again, so most effective is engineering controls, and then the least effective with the PPE. So that's why that should be the last step and the last line of defense to protect our workers. So now I get into aging and obsolete equipment. Like I said, we have a lot of older type of equipment. They were installed like around the 70s and early 80s when there was a huge expansion of the oil and gas industry. Pretty much during that time, the biggest market players were GE and Westinghouse. So that's a bulk of our older facilities still have these equipment, GE and Westinghouse. A few pictures of our substations. You can the doors are closed here. There's pretty much our aeromagnetic breakers with electromechanical relays still. Here's a few examples of the equipment that we still have. So let me tell you right away that these equipment have been very, very reliable for us. You know, they work, like I said, they work for a long time, and they're still working to this day. Just to the testament of our operations people and also our maintenance people at maintaining them. It's very important to maintain them. Like I said, we do arc flash studies. That clearing time is a big factor. So if you do proper maintenance, the relays will work. You know, if you're familiar with electromechanical relays, you've got that disc that spins around when it picks up the fault, right? So it spins around and then tells the breaker to open. So that breaker has to open within a certain amount of time. So they've had to be maintained, lubricated, and if not, then it may take longer to open. And in worst case, sometimes they don't even open. So that would be a very, very dangerous situation. So typical facility that we have one line diagram. So we still have the air magnetic breakers electromechanical relay. If you're familiar with this equipment, you'll probably be able to tell what kind they are. Then there's feeder breakers are the same, would be air magnetic. The feeder relays would be the same. So imagine if you were working on, let's say, one of the feeders and racking it in or racking it out, and for some reason it fails. You're pretty much relying on this relay to pick up that fault, and then you're relying on this breaker to clear to open, right, to interrupt the fault. So that's why, going back again to the clearing time, it's a very big factor. So now simplifying the diagram, so in the system you have the power transformer, so from transmission voltage, 69 kV, 115 kV, knocks it down to 15 kV class, 13.8 voltage. So you have power transformer, then you have the main breaker, feeder breaker, and then a large induction motor. And then the diagram on the right is a time current curve. Current on the bottom on the x-axis, time on the y-axis. And then, by the way, these breakers are, if you're familiar again with this equipment, Westinghouse DHP, it's an old air magnetic breaker. Westinghouse CO relays are electromagnetic relays. So that would be the damage curve of the transformer. That's the main breaker or main relay. Here's that feeder relay, and here's that motor starting curve. And if you ask me, well, is there anything wrong with this picture? I'm like, no. If you look at it, you see the motor curve. If you push start on the motor, it draws a lot of current. After a few seconds, it accelerates the speed, and then it goes into, it will draw normal current. The motor relay is protecting that curve. It's to the right of it. The main breaker, main relay is to the right of that feeder relay. So it's back up to that feeder protection, and then also protects the transformer from damage. So again, there's nothing wrong, but the issue is with arc flash. If you did an arc flash study on this.
Ritchie, 4 minutes.
Okay. So if you did an arc flash study on that particular system, you get the fault current, you have the clearing time, from doing the using SKM or ETAP or any other electrical engineering software. So as you can see, clearing time is 1.4 seconds, and then you have a voltage fault current. And then from those two inputs, then you get the arc flash energy, which is in this case is 22 calories per centimeter squared. So again, this 22 is based on these values here. So if your clearing time is much more than that, then, your study is out the window. It doesn't mean anything anymore. It could be 30, it could be 40, it could be 60, and who knows, right? If it doesn't trip, then that would be a very bad situation. The last section is doing mitigation solutions. So in Saudi Aramco, we recognized this hazard a couple of years ago, and we've put on some initial actions that to control the hazard, going to the engineering controls, administrative controls, and PPE. And this substation is actually the first arc-safe substation in Aramco, where we combine a lot of these elements to make it safer for the workers. And this basically is the model for the other substations that we have, totaling about 1,500 substations, throughout the kingdom. So an arc-safe substation would have remote racking. I was talking about remote switching, warning signs, and PPE. Also, the issue with these remote racking devices, if you think about it, the worker is standing several feet away. If there was an arc flash to occur, and if the energy was high, it probably saves the person, but it doesn't save the equipment. So if you think about it that way, yes, you didn't hurt somebody, but if the energy was high enough, then that equipment could be damaged significantly. Same thing with the remote switching, the middle picture. So that's the initial things that we do, but now we're getting into over the last few years doing arc flash analysis and then actively doing mitigation, like mentioned earlier. All the solutions that was presented, we use a lot of that solutions, doing the maintenance switches, doing the CSI and all the other things that was mentioned.
2
earlier.
minutes.
And I won't go into this deeply since it was already discussed. Maintenance switch, and now it's in our standards that we buy new equipment that it has to come with a maintenance switch for the low voltage breakers. And then we can do the same thing in the medium voltage side where you have digital relays that you have different settings groups where one setting would be normal settings and then a secondary setting would be for maintenance while workers are working on the equipment. And that's kind of a limitation that older relays, like electromechanical relays, would have because you're pretty much stuck with just one setting, whatever the setting is, and well, that's what it is. So the advantage of using modern relays is you have that option and you have that flexibility. And finally, to conclude, again, the main focus of this paper that I presented is protecting workers from excessive arc flash energy. And because of an emphasis on engineering administrative controls. So we're trying to go away from just PPE, but now we're doing the emphasis on engineering controls, mitigating the hazard, lowering the energy, and then doing some administrative controls. And then maybe, if the energy is low enough, then we can let the worker stand in front of the gear with the right PPE on. And so it improves survivability if an arc flash was to occur. And then lastly is aging and/or obsolete equipment doesn't necessarily mean less safe. Like I said, we still have a lot of this equipment. It's still operating today. Again, our workers are maintaining these equipment, and everything again is still online. So it's just the importance of doing proper PM. That's very relevant. So we have to do proper PM on equipment in order to keep them running, keep them within the tolerance bands of when we do our studies. We need those clearing time inputs to make sure they're within that range. And that's all.